Testing. Oh, it looks like my microphone is working.
Yeah, I hear you.
About 2 more minutes, we'll get started. Recording. Yep, recording. Okay, it's actually 11:59, but that's close enough. We'll go ahead and get started. Like I put in some of the emails, I will not be coding up the exact project today. I don't think it's fair to give you the answer source code to a project. So I will actually be coding up some things that will greatly help you whenever it comes time to project 2. And then if you have more specific questions, you can always email me and ask me those specific questions. So what I'm going to do is, since your project involves some GUI type operations, making a GUI, reading values from a GUI, and so on and so forth, I will be doing some GUI programming and showing you how to react to button presses, how to read text fields, and so on and so forth. This is being recorded, so if you need to go back and watch it, I will post a link for it sometime later today. All right, so since we're doing GUI programming, the first thing we want to do is let's get a window on the screen. And a window in Java world is called a JFrame. Just think of that as like the main window for your GUI application. I'll call it frame, and let's make one. Make a new frame. Okay? Excuse me, new JFrame. And that's the main window. Now, when we're talking about what's actually in your window, what are the components of it, we have what we call a J panel. And think of this as like a container that holds everything, all the components in your window. So make a new J panel. If I spell it right. Okay. Now, since the frame is the main window and the panel is like a container of components, we need to add the panel to our frame. So we do frame.add panel. And then to show that on the screen, you got to do a couple things. We have the function frame.set default close operation. What that means is this is what I want to happen whenever you click the little X box, in the top right corner of your window. What we want to happen is just, we want to exit the program whenever you click the X on the GUI. There's other things you can choose from. You can choose to just hide the GUI but not terminate the program. But we're just going to terminate the program whenever we click the little X on the window. We have another thing called frame.pack. After you add all your GUI components to your frame, you want to call frame.pack because that does a lot of the automatic layouts to correctly position the components in your window. Right now, we've only added this panel. As we go along, we'll add other stuff, but the frame.pack will correctly lay those out within your window. And then the final thing to actually show it on the screen, frame.set visible and true. That'll actually show that window up, okay? So let's just run this and see what happens. So I'll click my little, of course, I'm using the IntelliJ IDE. You can do this just in a normal text editor or whatever you prefer. I like using IntelliJ. With the little play button up here, it'll compile and execute the program. So run it. It actually pops it up on my other screen over here. I'll have to drag it over. And that's what we have. So the frame is the entire window. The J panel is what we call like the client area. This is where we'll later add components. If I click the X button, the X box, it should exit the program. The pack laid it out and the set visible just showed it up to me, okay? So that's good. Let's close it out. So that's our very first basic window up on the screen. So let's add a button. I know for your project, you're going to need to add a button. So let's add a button that does something when we click it. So we have a class called button. Let's call it button, and we'll make it a new button. And in here, we can put the text of what we want shown on the button. I'm just going to call it compute. We need to add that to our panel. You could add it to the frame, but you got to think of the frame as like the overall window, and panel is the actual components within there. So we want to add the button to the panel. Button. Let's run that. And I'll drag it over here. And there's what we have. So now we have a button on there. Of course, if we click it right now, nothing happens because we haven't put in code what should happen if we click it. But now we know we've got a button on here. Okay? Let's make the button do something. This is where Java gets into what we call listeners, meaning if an event happens in our GUI, I want this specific piece of code to run. And we can set up a listener specifically for the button like this, at button.add action listener. That means we're going to put some code in here that'll execute whenever the button is clicked. We can make a new action listener without. Luckily, IntelliJ does a lot of the automatic stuff for you. And so we have this method in here called action performed. And so whenever that button is clicked, whatever code you put in here is what is going to be executed. So for right now, to test it, let's just show a pop-up message window that says something. If you want a pop-up box, there's something called J option pane. Think of it as just like your normal little pop-up box to show on the screen. And we can call that dot show message dialog. There's a lot of different ways you can show stuff. Show confirm, show confirm. I'm just going to show a simple message. As you can see here, the first parameter is the parent. You don't have to have anything, but I'm going to use the panel. You could also use null here. It's just what is the parent GUI component for this. I'm just going to use the panel, and then we can put a string message. Let's just put a message to show. So what should happen is when I click the button, this code runs, and this code just shows a pop-up box. Let's run it. Drag it back over here. Now when I press the compute button, I get my pop-up box, right? And there's the text that I said should be in it. So I know that code is working, and you can do it multiple times. And every time, whatever code you have in here is what's going to take place whenever I click that button. Okay? What else can we do? Something else that you need to do for your project is you need to take user input, right? Okay. What I'm going to do for the rest of this example is I'm making like a simple calculator, okay? So let's take in two numbers, add them together, and display a result. That's kind of how we're going to play this out. So for text input, we have something called a text field. And I'll call it text field 1. It will be a new text field. And I want to add it to my panel. Panel.add text field 1. Something you want to add in here for text fields, and this is kind of important, we need to specify a size that the text field should be. If we don't specify size, it actually ends up on the screen very small and hard to see. So we have a function called set preferred size. And in here, we tell it what size we want that text field to be. Now, the parameter is something called a dimension. You don't just put, width, comma, height. We want a dimension, so we make a new dimension. And in here, we can put the width and height that we want that text field to be. I'm just going to make it like 64 by 32 large. Okay? So, let's run that, see what the text field looks like. And there it is. So I got my text field. I can type in whatever I want. And then my compute button just still shows that message dialog pop up. Okay. So now I've seen how to add a text field. Okay. Let's close it out. I said I wanted to put in two numbers, add them together, and display a result. So let's have another text field call this text field 2. It's going to be a lot of the same stuff. Add it to our panel. Text field 2. Okay. We also want, and I'm going to want to display a result in text field 3. The reason why I'm skipping here after the button is just preference about how I want the layout to look. I want to have the first number, then the second number, then the compute button, and then the output of the result. So we're going to put the result in text field 3. Again, another new text field. Got that. Assuming that should be a 3. Add it to our panel. Add text field 3. Excuse me, 3. All right, let's look at this. So now what we should have a text field, a button, and another text field. And there it is. So I can type whatever I want in here, whatever I want in here. And you can actually type whatever you want in here. Even though I intend for this to be the computer result, it's still a text field where you can just type stuff in. And of course, my compute button still just pops up right now, that message box, because that's still the only code I have in here is to pop up that message box. Okay? So now, like I said, my example here is going to be a basic calculator to say add two numbers together, right? When I click the compute button, I want to take the number in the first text field, add it to the number in the second text field, and display the results in the third text field. All right? So we need to get the text out of there and convert it to a number. So I'm going to have num1 is the integer. We're going to parse an integer from a string. What is the string? It's text field 1 get text. This text field 1.getText will get whatever I typed into text field 1. I'm going to parse it into an integer and store it in num1. I'm going to do almost the same thing, but for num2. I'll get it from text field 2. Let's compute the result. Num1 plus num2. And now I want to display that in the third text field. So I have text field 3 dot. I'm doing it wrong. Oh. 1 second. Text field 3. Yeah, I'm sorry. I do need to swap these around. The reason why I had to do that is because you cannot use a variable before you define it. And I define text. If I define text field 3 down here, then right here it doesn't know what it is yet. And so I have to define this text field 3 before I can actually use it. So my fields will be a little bit different, but it's fine. At least the order they're in the GUI. So I'm going to have text field 3 dot set the text. And I'm going to set it to the sum. With Java, you can't, actually, sum is an integer, right? And set text expects a string. So we need to give it a string instead of an integer. And a quick way you can do that in Java, Java's smart enough that if I take just these two quotes, which is an empty string, and add it to the number, Java is smart enough to understand that this is a string plus an integer, and it will convert that integer to a string for us. And so what I end up with in here is a string that's equal to whatever that number is, whatever that sum is. And then we're going to set that on text field 3. So let's run that. All right, what I have here is I have my first text box. Should put 1. The second text box, let's put 2. If I click compute, it should take this number plus this number and display the result here. And there it is, 3. If I change this to, say, 10 plus 22, compute, 32. Pretty easy. What happens if I type in A? If we look here, we're trying to parse an integer from this text field and store it here. This is not an integer, right? If you watch down here in the bottom left corner of my IDE, click compute, and I get this exception, number format exception for input string A, meaning right here, I cannot parse A into an integer. And so if I have my IDE, then this is going to be easy for me to find. If this is just a user using this program, they're never going to see this. And so we need a way to tell the user they put in some invalid information. So let's close it. So how do we catch exceptions in Java? Easy with try and catch. Now, I could specifically do number format exception here. That's fine. But what if something else went wrong? There probably nothing else with this example, but let's say we were doing division or something, right? You know, if number 2 was 0, then it's not a number format exception, it's an arithmetic exception, I believe, right? So there could be various things in here that go wrong. If you're very specific about the type of exception, then that's the only one you will catch. However, we can catch a generic exception, and any exception that happens in here, it'll catch it. Let's add it back to the addition. And if we get an exception, let's do another pop-up box to the user telling them, hey, you did something wrong. So let's go back to my J option pane. Show message. Panel will be the parent. And what we want to show them, we'll just put in the exception.toString. What that'll do, that'll take this exception and convert it to some kind of readable string for the user. And it should show this in the pop-up box. So let's run it. And bring my GUI over here. So now if I type in valid inputs, it's okay. If I type in something that doesn't make sense, compute. Oh, there's my message pop up. Java language number format exception for input string, whatever you put in. Okay. So maybe that's not very useful to the very end user. Let's say if you're creating a piece of production software. So let's actually just make it something that's easy to read. You have put in an invalid number. Something like that. Now if we run that and take a look at it, blah, 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 you have put in an invalid number. And you can make that string as descriptive as you would like, but I am satisfied with it as it is. Okay. What else do we have? Okay, the one more thing that I specifically have planned, and we can go and look into some other things, is, and this also has a direct tie-in to your project, because I believe your project says something to the effect of you need to remember the last 5 automobiles put in, or something to that effect, right? So I'm going to apply that, but just to my calculations here. So I want to remember, say, the last 5 or last 3 computations that were made. Okay? And that's, make sure we understand it's the last 3 put in, not the first 3, but the last 3. So if I put in 5 total computations, it should remember numbers 3, 4, and 5, and it should drop away the first 2. Okay? How I like to keep lists of things, in Java we have what we call an array list. It's an array that's easy for it to grow in size without specifically specifying the size. Inside these brackets, you have to tell it what you want, what type of array you want it to be. For me, it's going to be an integer, because my calculations, my sum is an integer. So I want to keep a list of integers. And I'll just call it list, and we'll make a new array list. So now I have a list that I can store integers in. If I wanted to store doubles, I would just change it like that, and I can store doubles. If I want to store an automobile, I can do it like that. I don't have a class automobile because I haven't done the project here for you, but one of your things is to keep a list of automobiles, and that's how you would do it. Of course, you got to have the automobile class. But for this example, I want to keep a list of integers. So anytime I make a computation, I want to add the answer, I want to add the sum to that list of integers. Okay? Easy, easy, easy. We have list dot add. And in here we put the integer that we want to add. And we'll add the sum. Easy enough. So now I can run this. Wait for it to pop up. So I can run this, type in some numbers, compute, type in some other numbers, compute, type in some other numbers, compute. That's fine. It is storing them in this list, but right now I don't have a way to see what's in the list. I'm not sure if it's working right. So let's make another button that we can show what is in our list. Let's make another button. I'll just call it show, new button. I'll put the text on it as show. Just like we have here, an action listener when the button is clicked, we need another action listener if this button is clicked. So if that button is clicked, what do we want to do? We could print it out to the console, which it means, system.out.println, or what I'm going to do here, I'm just going to show it in another J option pane just so we can have a pop-up message box to look at. Okay? So we'll have a J option. So we'll first start out with a string S. Right now it's blank, and that's fine. So we'll have a J option pane dot show message, and we want to show it on the string S. So obviously if we do this right now, the message is blank because the string is blank, right? But I need to put in this string everything that is in my list, right? So we need to loop over everything in the list and add it to the string. So let's make a loop for int I equals 0, I list n. To get the size of it, we have list.size. That tells us how many things are in the list. That right there will loop over every single integer that is in that list. And what we'll do, we'll just add the integer, the whatever I want to call it, just P, you can call it whatever you want. But you have to do list.get and put the index we want to get. So we're going to start at index 0. We're going to go throughout the entire size of the list. Each time through the loop, we're going to go to the next item. P is equal to the integer in this list at index I. And let's just add that to our string. just like we had up here earlier, well, it's gone now, where we have like string plus an integer. Java's smart enough to convert that to a string for us. So I have string equals the string plus this integer, and then I'm just going to put this is going to allow me to put a comma between the numbers. Otherwise, all the numbers will be bunched up together, but this will put a comma between it. So let's run this, and what should happen is when I click the list button, it'll loop over all the elements in the list, add them to this string with commas in between, and then it'll show it in a pop-up message box. Let's run it. Oh, I forgot to add my button. Oops. So let's close it. So we need to panel.add this show button. Everybody makes mistakes. All right. So here we're going. So if we click show right now, there's no message here, but that's okay because we don't have anything in our list yet. All right. So let's add 1 plus 1. We'll compute it, and that shows, and that's 2. So 2 should have been put in that list for us. Click show, and there's 2. 2 plus 2, compute. 3 plus 3, compute. 4 plus 4, compute. 5 plus 5, compute. And 6.6, compute. When we show it, that's all the computations we've made so far, right? But I did specifically say, you know, I only want to keep track of the last 3 computations that I've made. Just like in your project, you only need to keep track of the last 5 automobile computations you've made. So I'm keeping track of too many. Let's see how we can limit it. First, let's make a variable up here, actually a constant, that says how many do we want to keep track of. So let's call it a private static int max. Let's just call it max in list. And let's just say I want to keep track of 3. And this is useful because in other parts of your program where you want to know how many you want to keep in the list, you just use this, right? You should use this variable instead of the number 3. Because if you have the number 3 just some random place in your project, if you come back to this a year from now, you're not going to know what that 3 stood for. But if we use this, it tells us, it gives us meaning behind that 3. So where should we put it to limit how many things are in our list? And the only place that makes sense is right here. This is the only place we're adding something to the list. And so it makes sense that if there are too many things in the list, here's where we're going to know it. If there's 0 things in the list and we click compute, list.add, now there's 1 thing in the list. The next time there's 2 things in the list. The next time there's 3 things in the list. The next time there's 4 things in the list, and that's too many. So right here, after we add another integer to the list, let's see if our list is too big. So if the list.size, remember I told you that's how many things are in the list? If the list size is greater than the max in list, then we want to do something, right? This means our list is now too big. But what do we take out? Remember I was saying earlier that we want to remember the last 3 computations made, right? And so if you know your arrays, and you should know your arrays, you know that they start at index 0. So if we have, say, 3 items in a list, they are index 0, 1, and 2. If we have 4 things in an array, there's 0, 1, 2, and 3. 5 things, its indexes at 0, 1, 2, 3, 4. So let's imagine at this point, we added this sum in here, and now we have 4 things in the list. So we have indexes 0, 1, 2, and 3. Which one should we take out so that we only remember the last 3 that are entered? It makes sense that we need to take out stuff at the beginning of it. And we can specify what we want to take out of the list. We do list dot remove, and in here we put the index of the one we want to remove. So we want to remove 0, which is the first one put in. I hope that makes sense. So now, if things are over the maximum that can be in the list, we want to take the first one out, so we stay at that capacity. Let's run it, see what happens. It's got this. Let's show it right now. Of course, it's blank right now. Let's do 1 + 1, compute, show. 2, that's fine. 2 + 2, compute and show. 2 and 4, that's fine. 3, 3, compute, show it. 2, 4, 6, that's fine. Now here's where we're going to be able to see if it actually works or not. Meaning the next one I add should show up at the end, and the 2 should be removed. Meaning only 4, 6, and the next value I put in should remain, right? So let's do 4 + 4, compute, show. As you can see, the 2 fell off, and I've still only maintained the last 3 computations made. And that is all that I have prepared to show to you today. Basically, everything I've done in here should prepare you to be working and interacting with a GUI. The one thing I have not done as part of this is about superclasses and subclasses. You should be familiar with those things. If not, there's a lot of reading on it. But if you have specific questions about that, you can let me know. But I'm not prepared to show super and subclasses unless you have specific questions about it. Well, I'll give you one quick example of super and subclass, and then I'll take any questions. All right, so let's close this out. And this example isn't going to have anything to do with, oops, not Doro. Let's rename it to Door. It's not going to have anything to do with the GUI code. I'm not actually going to run it. So let's imagine we have a door, right? We have a constructor as a door, and let's say we have a string color, right? Let's see, string color, and we want to make a door, right? Let's imagine this is our main. Like I said, this isn't going to compile, and that's fine. For example, so let's say I have a door, new door, and I need to tell it what color it is because I said the constructor is going to take a color. Let's just say it's a red door, all right? So here I can have this dot color equals the color passed in. Okay, easy enough. So you can consider this like a superclass because a door is kind of a generic item, and you can have specific doors, right? Let's say let's say we want a door that has a lock on it. So we have public class door with lock. Now we could be very naive about it. Door with lock. Make its constructor. We could be very naive about it and also keep a color here, right? And then we'll save the color and we'll keep a Boolean whether it's locked or not. And we'll start off with it being locked. It is locked, okay? It's kind of naive about it though, because the door is a locked door is almost the same as a door. We're repeating the color here, not really necessary. So what we can do is we can make this a subclass of door. Sorry, my C language is getting mixed in there. Extends door. So what that means is whatever is in door, you're also going to have in door with lock, and you don't need to repeat it. So this color can go away. Why? Because I have color from here already. The door class is already giving me the color. All right. But what we have to do here is when you have a derived class, when you have a subclass of another class, you really need to call it its constructor within yours and use that with the super keyword, meaning this class I'm calling its constructor. It's expecting the color, so we have to give it the color. And there we go. Now we have a door with a lock that has all the properties of this door, but also extra stuff, extra functionality because it is locked. Now let's say we want to open the door. Public void open the door. Okay. And we'll have another variable in here is open. We'll make open initially false. We'll say it's not open. And open it, make it true. Okay. So now here's where things get tricky. Let's say we have this locked door. If it's locked, can we open it? We really can't because it's locked, right? So let's have a method called unlock, right? Let's spell it right. Unlock. And we'll say is locked equals false. Now it's not locked. Okay. And what we have to watch out for is if we still have this door open, but if it's a locked door, it's still locked unless we call unlocked, right? Door itself has no concept of what's down here in its subclass. What we can do is if we have a function with the same name, actually Java likes you to use the override keyword, open. That means instead of using this function, I want to use a more specialized version. So if I need to open a locked door, first I need to unlock it, and then I can do the normal open stuff. And the normal open stuff is covered up here in this door already. So now if I had a door, we can make it a new specialized version of it, like this. So this door, it's of this type, but it can be any of its subclass types as well. That's why I can say this door is equal to a door with lock, because door with lock extends the door. It provides more specialized functionality. So down here, I could say door.open. And so Java knows to use this open function because it is a door with a lock. And when it calls this, it's going to call the door with lock unlock function to unlock it. And then it's going to call these super classes open, which marks it as open. So that's your very basic super and subclasses. There's good reading material on the course website you can of course look at, but that's the basic of super and subclasses. So now I've given you in indirect ways everything that you need for project 2. Obviously not the code for project 2, but everything you need to be able to do project 2 as far as super and subclasses and all the GUI stuff as far as reacting to button presses and reading from text fields and writing to text fields. So my Zoom meeting will end in like 3 minutes. What I'm going to do is I'm going to end the Zoom meeting here in a second. I will start a new one for question and answer session, and I will immediately email that out. So look in your emails for another invite in like 1 or 2 minutes for another session that will be for questions and answers. If you don't have any questions and answers, that's fine. But if you like questions and answers, please come back. This video is being recorded and I will have it posted up sometime later today, and we'll email that link out as well. All right, so I'm going to end it now and look for the email for the next meeting. Thank you.